Johannes and I are having a competition to see who can speak the most number of times. And so Johannes had the third chance this morning, and I've got my third chance this afternoon. So thanks very much for this invitation. This is something that, to the best of my knowledge, we have never had at FIRE. And we very rarely have in computer science. Because in computer science, if you want to know you're doing the right thing, you measure it. But in the humanities, if you want to know if you're doing the right thing, you discuss it. Right? And so there's this tradition in the humanities. If you ever go to a presentation by a humanities scholar, there will be another presentation immediately following it by a discussant. Right? And the idea of the discussant is to somehow take a different perspective on the same topic as the original presenter, because in the humanities, knowledge is advanced through discussion, because they simply can't test it. Right? So this is something I think that in our community we could borrow from, perhaps in the next FIRE. We could have a discussant after each track presents that reacts somehow. Sometimes this is called a reactor or a reactant. React somehow to what had happened. Or after hearing this talk, you may decide that you never want another discussion. Right? So that's the beauty of experimenting. Now, I don't know anything about cross-language Indian news story search. But that doesn't keep me from having opinions. So I will do what politicians normally do. And no matter what question you ask, I will talk about what I want to talk about. Right? And it turns out that early in my time, I had done some thinking about comparable corpora. I was very enthusiastic about comparable corpora. In particular, the sorts of things you could do with late semantic analysis, the comparison condition for the talk that we just heard. And so I have, over the years, been trying to figure out what in heaven's name it would be useful for if we knew of related stories. Right? And I can come up with three basic ideas. One is we can find related terms. So this is the work of Pascal Fong. She did a PhD at Columbia University, graduated in the mid-1990s, and the idea was that we were going to move away from all of this black magic parallel text thing, and we were going to go to comparable corpora, and we would find the translations for the words that we needed. There are a couple of little problems with that. One is that in comparable corpora, we don't have word order to take advantage of. And so we need many more repetitions before we can have high confidence, and therefore we need astronomically large corpora, which didn't exist in the mid-1990s, and which only exist in some places now. And so parallel text gets more mileage out of a given size corpus by an order of magnitude or two. I mean, it's just an enormous difference. As a result, the problem with parallel text is that in the long tail, you have poor statistics for the translation probability. So words that don't occur very often, you don't know much about. But in comparable text, you can't see very far into that tail. So all you can learn is the translations of common words. And of course, common words is what we find in dictionaries. So this fell out of favor after a while among people who were interested in natural language processing. There was sort of a specialized group of Pascal followers who had workshops on this topic, but it didn't really change the world much because of this problem with needing very large corpora